Ladies and gentlemen, we have a mystery to solve. It seems that X has gone missing. That's right, we need to find our favorite variable X. Now, it was last spotted in an equation headed south through Collinsville on its way to Airville. So, to figure out its value, we're going to need our best algebra agents. Agent number 1, you're going to need our equation converter. Agent number 2, you'll need to slap it with a log. Agent number 3, get out the ace of base. Agent number 4, bring along your equation condenser. Are all algebra agents ready? Yes, sir. Then ready, set, solve. Now, algebra agents, if you would like, you could take out a piece of notebook paper and fold it into these 4 sections. If you don't want to, that's all right. Make sure you still take notes because we're going to have 4 different categories. Now, the first category is going to be a basic exponential. Now, a basic exponential equation, the good news is you've already solved. Yes, we've already solved an equation like 6 to the x equals 99. Are you feeling like that this is a log equation? Are you feeling like that you can convert this to a log? Well, it will always be able to be written as a log base, right, base 6. So log base 6 of 99, and that will equal x. Now, we're trying to solve for x, so make sure we know how to use our calculator to get the value of the log base 6 of 99. And it's been a division problem. Yes, it's been a division problem because it's called the change of base formula. So that's all there is to it. You take this equation, you convert it to a log, and ultimately you divide on your calculator the 2 logs to find x. Now, we like to say that for a basic exponential equation where x is in the exponent, all you got to do is convert to a log and then use that change of base formula, which means divide the logs. But some exponential equations are a little more advanced. And so if we have an advanced exponential equation, like 2 times 3 to the x plus 4 equals 350. Well, it's not going to be quite as easy as just converting it to a log. But no worries. We still have x in the exponent, and whenever x is in the exponent, you're still going to use logs to solve the problem. Now, what I'd like to tell students, algebra agents, is that you first and always want to isolate the heart of the equation. The heart of the equation is the part that has got the variable. So what that means is that we're going to need to do something with that 2 out front. And like you've always done, you want to do the opposite. And so we divide both sides by 2. And what we're doing is we're starting to isolate the heart of the problem. Now, after you divide by 2, what you want to do is get out your log, because we're going to slap both sides with a log. What do I mean, slap both sides with a log? Well, I mean you're going to do the log of both sides. You mean I can just do the log of both sides? Well, yes, as long as you do it to both sides. Now, here's the main reason. See that x up in the exponent? Remember that property of logs? That's right, the exponent comes tumbling down. That's what happens when you slap both sides with a log. The exponent comes tumbling down, and it is now in front of the log. So I have an x plus 4 in the front of the log of 3. Now I also have the log of 175 hanging out over here. Now don't worry, I know this looks a little complex, but all we did was divide both sides by 2 and then slap to both sides with a log so that the exponent could come tumbling down. Now, we're almost there. You see, the log of 3, that's being multiplied. Just divide it. Yes, divide both sides by the log of 3. Feel like you've done that on your calculator before? Well, you have. So you take the log of 175 divided by the log of 3 on your calculator. Go ahead and do it. Make sure you get 4.701. And look, all you have left to do is subtract 4 from both sides. And once again, you've solved for x, this time equaling 0.701. So when you have a more advanced exponential equation, where x is in the exponent surrounded by other numbers, you first want to isolate that exponential part, but then you're going to slap both sides with a log, and the exponent comes tumbling down. Now, Mr. Naylor's not making this stuff up. It works every time. So what if we had 9 to the x plus 10 plus 3 equals 81? Are you able to see the exponential part? It's always going to be the part that contains the x. It's always the heart of the equation. And just like we've done all year, you always want to isolate that part. So subtracting 3, yes, subtract 3 from both sides. And what that does is that gives me the exponential part all ready to be slapped with a log. Now, when you do the log of both sides, the exponent always comes tumbling down, and now it's down in front. Now it's being multiplied by that log of 9. See how this works? Since you're multiplying by the log of 9, you are free to divide. And we always end up dividing two logs when solving an exponential equation. So like I said before, make sure that you can do that on your calculator. Take the log of 78. Make sure you have those parentheses around 78 if your calculator requires it. Divided by the log of 9. Divide that on a calculator and just double check that you're getting the right number. Double check that you're getting 1.983. Because all we got to do is subtract 10. And once again, we've solved for x. Good job, algebra agents. Now, what about this exponential equation? Remember, exponential just means that x is in the exponent. But look, we've got this strange base. It's called a base e. Now, because of the time constraint at the end of the year, we're not going to have a lot of time to talk exactly about what is this base e, but I want to show you that we can still solve the equation by using the same steps. That is, you want to isolate that exponential part. Right, you divide by 2. You always isolate the exponential part. Now, are you ready? We're going to slap both sides with a special log. It's called the natural log. No, not a natural log like literally a piece of wood, but the natural log that matches with this base e. You see, what we're not going to have a lot of time to talk about is that e is a special number. It's the natural number. And so to slap both sides with a natural log is going to cancel that e. Now, what I just wrote down there is called the ln. It stands for natural log. And what I want you to know is that anytime you have an e, you're always going to cancel it with an ln. It works the same as any log. It makes the exponent come tumbling down. But one thing that's a little bit different is that you don't have a log anymore on the left side of the equation. And that's because that ln canceled entirely with the e. And it all disappears, and we're left with just the exponent. And of course, x plus 1 equaling the log of 30, that's something you can do on your calculator. You just have to find the natural log button, which on my calculator is right underneath the log button. It says ln. So if you do the ln of 30, you end up with 3.401. All right, so of course you're going to subtract 1, solve for x. But I know what you're thinking. I don't know, Mr. Naylor. That was kind of different. Well, here's the thing. If you see e, you're going to use a natural log. And the only thing that's really different is that that natural log is going to completely cancel with that base. So we're not going to have e anymore. We're not going to have a log on the left side of the equation. We're just going to have the exponent. All right, so slap both sides with a log. Now, algebra agents, are you ready for our next kind of equation? It's a logarithmic equation. Now, here's the thing. A logarithmic equation is an equation that starts with a log. Like maybe the log base 3 of x plus 7 equals 5. Now, if the equation starts with a log, we don't want to use a log to try to cancel it. No, we don't. We want to pull out the ace of base. What am I talking about? Well, this problem is a base 3. And if I do a base 3 to both sides, now, what do I mean if I do a base 3 to both sides? Well, what that does is it cancels with the log. And on the right side of the equation, it creates an exponent situation. It honestly creates 3 to the 5th power. So it pushes that 5 up as an exponent. Now, my x plus 7 is able to come down because the log canceled. But 3 to the 5th power, well, that's going to be a new number. That's going to be, on your calculator, 243. So, just like we've done many times, I can finish the problem. I can solve for x, I can subtract 7, and we end up with 236. So, what just happened here? Well, we started with a log equation. There was a log in the original problem. And so we used the ace of base. That is, we based both sides. And notice that you base both sides with the same base. And that will cancel the log. Are you ready to try it for this log equation? Remember, if you start with a log, you're going to end up basing it. But hold on. You always want to isolate the heart of the problem. Yes, for this problem, the x is with the log, so we put a box around that log that tells us that we're going to want to divide by 6. But get ready. Get ready, because we're going to base both sides. You say, but there's no base. Remember, if there's no base, we assume it's the common log. Right, and so what's the assumed base on a common log? Yes, it's a 10. So we're going to base both sides with a 10. What do I mean to base both sides with a 10? Well, it cancels with the log. But over here on the right side of the equation, we get 10 squared. Yes, it makes 2 become the exponent, since 10 is the base. And, of course, 10 squared is 100. And all I got to do is divide both sides by 4. We found x again. Good job, algebra agents. Let's try a log equation that uses this natural log. Now, I know I just introduced this natural log to you, but it works the same as any other log. It just has a special base. Yes, a natural log has a base e. It's not shown either, but it's assumed and it's there. So, what's our ace of base for this problem? Right, it's an e. You want to base both sides with an e. It cancels with the natural log. It leaves you with just x minus 3. But on the right side of the equation, you have to do e to the 4th power. Now, that'll require finding the e button on your calculator. Everybody's calculator is a little different, but most people's E button is with the LN button. On this calculator, it's a second option. So I find that E to the X button, and I do E to the 4th power. Go ahead and try it on your calculator, because you want to get that 54.598 number. All right, because it's going to be pretty easy to just add 3 to that, so we can have our final answer here for X. Okay, algebra agents, when you have an ln, it's still a log. It's just called the natural log. And it's going to be based with a base e, which requires you to use your e button. So you can, in this problem, you can do e to the 4th power. Algebra agents, you made it to the 4th kind of equation. Now it's advanced logarithmic. And it doesn't mean it has to be hard. It's just a little more advanced. It's going to have an extra step. So, look at this log equation. First off, it is a log equation. It clearly has logs in it. But look, it's got 2 logs. Now, before you just say, Mr. Naylor, a sub base, right? Base both sides with a 10. Well, you're close, algebra agents. You're close. I like that you're thinking. But the wonderful rules of algebra don't allow us to do multiple bases on one side of an equation. So, here's what we do. We have to first apply a property of logs. We have to condense these logs. We have to pull them together to be 1 log. Remember how to do that? When you have a plus sign, you pull them together to be 1 log of a product. That's right, the product of 2 and x. So we condense the 2 logs to be 1 log of 2x equals 3. And now, doesn't it look a lot like the problems from before? That's right, we can pull out the ace of base. And it's going to be a base 10. You always use a base to cancel a log. Now that leaves you with just 2x, but it leaves us with 10 to the 3rd power. 10 to the 3rd power is 10 times 10 times 10, a full 1,000. And so x equals 500. So, when you have multiple logs, you always want to condense to a single log before you base it. We want to condense to a single log. All right, you'll recognize an advanced logarithmic problem. It's always going to have those multiple logs. Okay, so we want to condense, which uses the properties that we studied the last couple days. Now, we know we're going to pull this together. We're going to pull these together to be 1 log. And look, it's a subtraction, so we're going to make a fraction. But the common mistake in this problem is for students to forget that we always need to first move these coefficients. Yep, before you can write 1 log of 1 fraction, you got to force yourself to make this into a 4 squared. Careful, because that's probably one of the most common mistakes, so I'll say it again. You always want to move a coefficient up as an exponent before you get into the actual condensing. All right, so algebra agents, we have a subtraction sign. Subtraction means fraction, and whatever's being subtracted ends up in the denominator, and whatever's being added ends up in the numerator, right? Except 4 squared is the same as 16. All right, so we condense this to be the log base 2 of 16 over x equals 3. Now, algebra agents, a sub base, right? A sub base, you're allowed to base both sides. Leaves you with 16 over x, and it leaves you with 2 to the 3rd power. 2 to the 3rd power is not 6, but it's 2 times 2 times 2. 8. Now, if you look at this equation, it's a little different than ones we've had before because we have a fraction and we have x in the denominator. Well, don't forget your algebra skills. Some years gone by, algebra agents. Maybe you want to cross-multiply this problem. Maybe you want to cross-multiply. But it looks like x is just going to equal 2. Let's look at one last equation, and we better do one with the natural log because I want you guys to realize that natural logs follow the same properties of any log. Now, do you see it? Right, we've got 2 logs. You gotta condense this. You gotta condense it. Now, both of these natural logs have coefficients. So, all right, we'll bring both of those coefficients up as exponents. Now we have the natural log of x squared. Now we have the natural log of 3 to the 3rd. Okay, So after you move those coefficients up as exponents, you're able to condense this, because it's a plus sign, into one natural log. Write down one natural log. Now, 3 to the third power, that's 27, x squared. And there we go. We've got our product of 27 times x squared. Are you ready to base both sides? Algebra agents, what base do we use? E. That's right, base, E. You base both sides with an E. Remember, base E is always going to cancel with a natural log. You just got to figure out e to the 7th power on your calculator. Now, e to the 7th power, it's going to be a big number, 1096 with some decimals. Leave it on your calculator, because all you got to do is divide by 27. So leave all those decimals on your calculator, divide them by 27. So we get x squared equaling about 40. But leave that on your calculator so that you can take the square root of both sides. Now, the square root of 40 is about 6.3. But this time we don't want the plus or minus. We don't want the plus or minus because you can't do the log of a negative number. So, because we had an x beside the original log, it's not going to be able to be a negative x. All right, no worries. It just means we get 6.373. Now, algebra agents, remember, sometimes you can just convert the problem if it's basic. But if it's advanced, you're going to have to slap it with a log. And maybe it'll be a natural log. Of course, the ace of base. But you have to condense to a single log before you base it. Algebra agents, great job solving for x. Now, to end your mission, you got to do your homework. So do it well and check it with the selective answer key.